Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about magnetic sensors. Magnetic sensors are devices that detect and measure the magnetic field. They are used in a wide range of applications from simple compasses to say sophisticated medical imaging equipments. The basic principle of behind this magnetic sensors is the interaction between a magnetic field and a sensing element, which can be a material that changes its electrical properties in response to a magnetic field or a mechanical system that is deflected by the magnetic force. So let us see the different types of magnetic sensors. So there are different types of magnetic sensors which are say Hall effect sensors, magnetoresistive sensors, then flux gate sensors, switch sensors, and search coil magnetometers. So let us see each one in detail. So first one is the Hall effect sensor. So this is one among the most widely used magnetic sensors. They operate based on the Hall effect, which is the protection of the voltage difference across an electrical conductor. It travels to an electric current in the conductor and a magnetic field perpendicular uh, to the current. Mm, so the principle of operation here is when a current carrying conductor is placed in a magnetic field, the moving charge carriers experience a Lorentz force which deflects them to one side of the conductor. This charge separation creates a voltage difference which is known as the Hall voltage, which is proportional to the magnetic field strength. The advantages of this is it is very simple, robust, and can measure static magnetic fields. So main disadvantage is that it's relatively it has low sensitivity when compared to other types of say sensors, and it has temperature sensitivity. So some of the applications here it is used in position sensing, then speed sensing, current sensing, proximity detection in automotive, industrial, and consumer electronics, etc. So next one is magnetoresistive sensors. So here the principle of operation is that the resistance of the MR material changes depending on the strength and direction of the applied magnetic field. There are different types like say AMR sensors, which is nothing but anisotropic magnetoresistance, giant magnetoresistance, which is known as GMR, and tunnel magnetoresistance, which is known as TMR. So AMR sensors they exhibit a change in the resistance due to the angle between the magnetization direction and the current direction. GMR sensors it consist of multiple thin layers of ferromagnetic and non-magnetic materials. So the resistance changes significantly when the magnetic alignment between the layers gets changed. TMR sensors are similar to the GMR sensors, but with a thin insulating layer between the ferromagnetic layers, allowing for even higher sensitivity. So the advantages here is that the higher sensitivity than the Hall effect sensors. It has good linearity and wide frequency range. Disadvantages is more complex fabrication, can be more expensive than the Hall effect sensors. And application is it's here also it's used in position sensing, angle sensing, magnetic field measurement, etc. Next one is flux gate sensors. So they it's a high permeability. It has a high permeability core and is driven into saturation by an alternative current. An external magnetic field affects the saturation characteristics of the core, producing a voltage that is proportional to the external field. So advantage here is it also has high sensitivity, it has low noise, and it's capable of measuring very weak magnetic fields also. Disadvantage is relatively complex circuitry and it has high power consumption. Applications are say magnetometers, navigation systems, geophysical surveys, and space exploration. It's also used in metal detection, etc. Uh, Next one is say squid sensors, which is nothing but superconducting quantum interference device sensors. So they consist of a superconducting loops containing junctions. So the current through the junction is extremely sensitive. Uh, to change in the magnetic flux threading the loop. So it also has advantage of high sensitivity and capable of measuring extremely weak magnetic fields. And its disadvantages, it requires cryogenic cooling, so which is a little bit difficult and it's very expensive. Applications are it is used in medical imaging and geophysical research, and it's also used in fundamentals of physical researches. And finally is the search coil magnetometers. So based on the Faraday law of induction, a changing magnetic field induces a voltage in the coil of wire. Um, the magnitude of the induced voltage is proportional to the rate of change of the magnetic field and the number of turns in the coil. So advantages are it is a simple construction and it's relatively inexpensive when compared to other types, and it is good for measuring AC magnetic fields also. Disadvantages, it is not suitable for measuring static magnetic fields, and its sensitivity depends on the frequency of the magnetic field. Applications are it is used in electromagnetic interference measurements, then geophysical explorations, metal detection, and also magnetic anomaly detections. So let us see few applications of uh, magnetic sensors. So they are used in applications like say automotive industries, then in industrial applications, consumer electronics, in medical applications, in aerospace, and also in geophysics. So thank you for listening here for this video. So hope you understood what is magnetic sensors. So let us take up some assessment questions. Which sensor type is primarily used to detect the presence and strength of the magnetic field? Yes, the answer is magnetic sensor. Next one, magnetic sensors are sometimes referred to as what type of device, as they detect a physical change and convert it into a measurable signal. Yes, the answer is transducer. And the last one is which of the following is a common application of magnetic sensors? So the answer is detecting the proximity of a metal object to a machine. Thank you for watching this video.